All right, so I'll just give a basic overview. We do have certain textbooks. They are mentioned in this orientation document, which you all should have received. Uh, Please read the orientation document carefully. If you have not subscribed to the Slack discussion channel, please do. It's important because I wouldn't have the luxury of posting or sending emails all the time. And other people would like to chime in into the discussion. It's much better we do it over a discussion group rather than through emails. Right? So please do subscribe to the Slack. Those of you who haven't must do. This is anyway our stuff that we did last time. If you remember, we went over the basics of machine learning and so on and so forth. We talked about a workshop will include the following features. What were the features we talked about? A workshop to include. Let me go back. We'll have lab work, we'll have projects, we'll have quizzes and data science interview prep. We will have polls. Guys, the less than half of you, only a third of you fill the polls. It just takes 10 seconds. Can I please request that if you haven't filled the poll after the last lecture, you have an invite to that. Please do complete the polls. It's important that we take the polls and participate. Likewise, discussion groups, if you haven't joined, please do join it. Now, I wanted to announce, and then YouTube. We have a YouTube channel. Now, why is that important? This Sunday on YouTube, actually, we'll be doing 2 broadcasts. One of them is a slightly technical topic. It's on word embeddings, a simple understanding of word embeddings. It's a very interesting topic in machine learning. You guys are all ready to understand it. So think of it as an additional content besides the workshop. It is at noon on Sunday. Watch our YouTube channel and certainly do, if you subscribe it, you'll get notifications about it. The second is I'm going to give, for those of you who are not very familiar with Python or would like a bit of extra help, I'll give a hands-on walkthrough of Python through a notebook. That will happen around 1:30 or 2 o'clock. I'll be giving it on YouTube and I'll take questions in the YouTube's live chat and provide explanations. So for that reason, if you have not subscribed to the YouTube channel, I would strongly suggest that you do. Are we together? That's that. Likewise, we have a Facebook and Twitter channel. So what I'm doing is notifications I try to push out to each of the channels, but not everything am I able to push out. Some things which are very specific to this workshop, which are not for public consumption. Like for example, this Python talk, I'll be putting it only on the Slack channel. Right? So that is that. Now, today, I expect us to finish a few things, guys. Let me mention what I expect we do. I would like us to do the following. I'll talk about Kaggle. Kernels. We will set up Colab in GCP. GCP. We will set up, for those of you who have good, powerful machines or who are willing to pay in GCP itself, I will show you how to set up Jupyter notebooks or notebooks in notebooks. Notebooks in GCP, that is if you want to do faster computation, need more memory and so on and so forth. Are we together? And for local setup, I'll give you an idea of local setup. So this is the scope of what we are going to do. We'll talk about homeworks and projects. Speaking of projects, so homeworks, the way it will work is every week a homework is due. This homework you will post directly to Kaggle. So I've created a data set, a private data set, where you can submit your homework. So one thing that I need from all of you right away is go to Kaggle. If you haven't registered in Kaggle, by the way, you can register to Kaggle using your Gmail accounts. Right? Once you do that, confirm that you are registered in Kaggle. Then I will show you a data set, a simple data set that we have. This week, I'm making the assignments rather simple, right? The homeworks are rather simple, but going forward, it's going to be a bit more involved, because the whole idea is that this class is about a lot of practice. We'll continue the tradition hereafter. Mondays will be theory, and Wednesdays will be a review of labs, walkthrough of code, and walkthrough of the projects. So let me start by first sharing my screen and talking about Kaggle. Is there anybody who's not familiar with Kaggle or what Kaggle is? If you're all familiar.
I'm not familiar with Kaggle.
Okay, so then I will talk a little bit about what Kaggle is. Where am I? So are you guys seeing my screen?
Yeah.
Yes, we see your screen.
I can change the settings for automatically admitting everybody. I don't know why I have to enable people to join this. I don't know. Anyway, that's some setting. I don't know. All right, if you're seeing this Kaggle, let me give you a background.
Asif Srinivas here. So this has been the security setting from the Zoom because of the Zoom moments in the past.
Oh.
So if you could make somebody else on the host, like Prachi or some other TA,
right,
that will help you get over this issue.
All right. I will do that. Let me do that. Make host. Prachi, you are the host now.
Yeah, I can see that.
And if you notice anybody in the waiting room, please do admit them.
Yeah.
Thanks, Srinivas, for explaining to me. This is very interesting. So random people come and join your Zoom, is it?
Yeah, that's true. And then people can share whatever, right? So that especially with the kids and all, some people have got some not so nice pictures on the meetings.
Oh,
and that was the issue.
All right. Explains. So Kaggle is a site which has been very influential in data science. The reason I am emphasizing this is because if you want to be considered seriously in this field, you have to have a presence on Kaggle. Are we together? I'm making a pretty strong statement here. Well, having said that, I belong to a generation that used to not be very active in Kaggle. I myself have not been active in Kaggle for reasons that now in hindsight I can't explain, because I've been very busy with work or whatever it is. But I wish I had time. If I was younger, I would certainly be very active on Kaggle. If you're joining data science as a field, you aspire to have a career in it, I would strongly suggest that you do have a presence on Kaggle. What they do is they post a lot of data sets. They are a curator of data sets. I believe the total number of data sets they have is, if we go here, do you notice that? What they have done is they have collected data sets, all publicly available data sets from everywhere, and they are hosting it. There are many other sites that are doing that, but Kaggle is certainly the most influential these days. Most of the things that people talk about are here. Now, when you have a data set, you notice that today we are in the middle of a COVID situation. So if you go home and you look at what is happening here into the data sets, you will realize that the COVID challenge is this. There is this data set. Government has said it's a challenge. Let us all try and solve the COVID's research, or at least facilitate research into COVID. The moment you do that, what you can post your data sets in Kaggle, and then, these are massive data sets, as you can see, 13 gigs of data set. You can then specify what do you want people to do. So you notice that the researchers have said these are all useful things they want the data science community to do, or help make possible. Right? So these are the tasks. You give certain tasks. Then there is a discussion board associated with a particular data set. A lot of people are discussing all sorts of things here. And it's a conversation, about the data. You have a fairly large amount of activity. It shows how much people are engaged with it and from where. Clearly, people from the United States and India are dominant in this particular challenge. And this is, by the way, an emerging trend. India is emerging as a data science powerhouse. It's quite interesting, actually, that you find so much talent emerging in India in this new field. So, and then you have the kernels. So what are kernels? Kernels are notebooks that people have posted in this space. And you can look at the kernels by how much votes they got. So for example, here is a person who has created a kernel. I'll just take the most popular kernel. It seems to have been voted on 1,094 times. What it means is, if you are here, look at the beautiful way. This is what is called a notebook in science, in data science, you call it. Now, most of you who have done something are familiar with it, but roughly speaking, in programming, you write code, and maybe you put some comments or you don't put some comments. In the world of data science, there is something called literate programming. The idea is that when you code, typically in C or Python or some language, let's say Python for general purpose coding, you're trying to make the machine understand your code. Whereas in data science, there is a difference. When you write code, to a large extent, your audience is other data scientists. You're trying to explain your code to other data scientists. Right? And that's a huge differentiator. So the way you do it is comments dominate. What you would consider comments in code, it actually dominates. Are we together? Right? And so most of these notebooks are full of comments. By the way, I don't know, yes, they're full of comments, and you can clearly see this notebook has pictures and descriptions and so forth. They usually don't call it comments, they call it documentation or text or something. But in the language of programmers, you would say a lot of comments or documentation. But very neatly, this person has documented everything, what it is, what data he's working with. He's doing exploratory data analysis and so on and so forth. Okay. And it's a pretty long notebook. If you notice in this notebook, he has used a lot of features. He has colored the columns as he's looking at the data. He has given the top end. Those of you who did exploratory data analysis with me before know what I'm talking about. I expect these things to you. So for example, if you go back to the, let's compare these methods with what I've been teaching you. Supportvectors.com. If we go here, and by the way, it is there in your Slack, but I'll just go through this website, supportvectors.com. If you search for example, covariance, I think I gave a page with that. Are you folks seeing this? So when you look at this, and this is the notes from the previous workshop, those of you who took the introductory workshop with me, and those of you who didn't, if you have had exposure to basic data analysis somewhere else, This is it. Those of you who have not, who are completely new to any data science or statistical analysis, do please attend the extra session that I'm giving over the weekends. So this is it. And I want to give you a sense, since we covered these things, those of you who have been familiar with this, I suppose, do you notice that we went through a systematic process of data analysis?
Yeah.
Yeah. So this whole data analysis that we went through, and for example, by the way, what you're looking at are chapters from my emerging textbook. In due course of time, I would like to finish it and get the volume 1 out, which I hope will be before this month ends.
So Asif, can you maximize the screen?
Can I maximize the screen? There we go.
Yeah.
Is that better?
Yes.
So, so I take an example of the IRIS dataset, for example, which is the quintessential example that everyone starts with. We do exploratory, basic exploratory analysis. We draw graphs and plots and so forth. We do bar charts, correlations, pair plots. Then likewise, the California dataset, you do all sorts of visualizations and so forth. You do, as you can see, we do different sorts of visualizations of the data, correlations and so on and so forth, and missing value analysis. So I'll just stop here at some of these plots and compare them to what you see now happening. Let's see, you're looking at this COVID data set. So what do you see? Do you see a similarity? People go about the data in a systematic way. This notebook is well done. It has studied the data. It has done a very good job of exploratory data analysis, explored the data. And you can see that if you systematically do the data the way I have taught you guys, my feeling is that you will get quite a lot of recognition in the field. Generally, highly voted people in Kaggle, it becomes very easy for them to have job conversations with companies because their work is already showcased. And the way we will do this workshop is I want to make sure that you all right away create kernels in Kaggle, high quality kernels. And of course, I'll guide you in improving those kernels so that you create a set of assets which you can showcase in your interviews or in your, or talk about with your future employers. So you notice that there's a lot of descriptive statistical analysis done by here. Now, what does it take? How do you do all that? It's very easy. This is nothing but sort of a Jupyter notebook. Those of you who are familiar with Jupyter notebooks, you can do it. Now, Kaggle has one limitation. It accepts notebooks only in Python and R. It doesn't accept notebooks in Julia. But in this workshop, I will expect you to do also your notebooks in Julia. Give me 1 second, guys. I'm getting the sun directly in my eyes. Yes. So we'll also do that. Anyway, so that is the Kaggle aspect of it. Let's go back to home. So what you should do, what we will do is, we will take a few data sets as homeworks and a few data sets as your projects. For projects, it's important that you find your partners as soon as possible. And just to get you practiced with the new way that you need to do, this time around, I will take submissions only as Kaggle submissions. Are we clear, guys? And I will leave it to you to decide at the end whether you want to make those notebooks public. In the beginning, your notebooks will be private. I hope only we can see it. But gradually, they will start becoming public. Huh? So what are the data sets we are going to talk about? The data sets that we will talk about are, if you search for something called the river dataset, for classifiers. I have sent a link on Slack to all of you for this data set. Are you guys able to see this page?
Yeah.
That's right. So this page, and you can see it as a stranger, etc. If you see it as an anonymous person, it will look to you like this. Let me go into the anonymous mode. This. Oops. You can't see it. We can't find this data set. That's not very encouraging. So let's see if you can even see this. Yeah, so you need to, at this moment, you need to, yes, it will not even show up in search. So in other words, you have to be logged in as a user, and I have to give you access to it. Right? What this data set is about is it has two fields, X1 and X2, and there is a target variable T. T is categorical. It has values of either 0 or 1. You can see that right here. It has only two values. Most of the values are 1. Some of the values are 0. X1 and X2 are numerical fields. Your first assignment is a very simple assignment. Just write in either R or in Python, create a classifier. Right? Now, the way you have to do that is, depending upon your level of expertise, if you're completely sort of entering this field, do at least this much. Pick up enough so that you can do an exploratory data analysis. Now, remember, guys, this analysis is all due before Monday. Right?
Asif, the text is not visible. Right?
Asif, if people click on the link which you have shared on Slack, I think you don't need to sign in. You can still see the data set.
Oh, because I've given a shareable link. All right. Yeah, go to Slack.
Yeah, I see the data set.
You do see the data set. Wonderful, wonderful. Let me also try that just to see how it looks to others. I use, where am I? Kaggle. Give me a moment, guys. Copy, and let me go here. Yes, so this is how it should be looking to you at this particular moment. Does it look like this, guys?
Yeah.
Yes.
Yes, so I've given the instructions here. You need to do exploratory data analysis. By now, you know what exploratory data analysis is: univariate statistics, mean, median, modes, and all of that. Bivariate statistics, the correlations and so forth, right? The pair plots. Do some visualization of the data. It's a very simple data, two-dimensional data with some data belonging to one class and some data belonging to the other class. Then you have to create classifiers. The first task is you need to create an effective classifier using only logistic regression. Don't use anything else. First, in your notebook, there should be a section that says, using logistic regression, it is this. You're allowed to do feature extraction. So before you do logistic regression, as part of your exploratory data analysis, if you can extract a few features from the data, that would be absolutely marvelous. See if you can do that. And you try to get a better model using logistic regression. Now, let me just mention that just with logistic regression, you can achieve accuracies in the 90%. Right? So the trick is, how do you get there? Initially, I thought I'll make it just as a competition, but then I thought, let all of you see each other's notebooks and learn from it. Then what do? Try, if you know any other classifiers, and we'll talk about other classifiers today, go use those classifiers to train on this data and do that. But logistic regression, you must somehow achieve close to 90% accuracy using just logistic regression. And the assignment is to be able to do that. The bonus is go use other classifiers and try to get these results. Obviously, today I'll talk about the other classifiers. For many of you, this may be the first time you're creating a notebook for Kaggle. Now, how do we do those notebooks? There are two ways that you can do that. First, what I would suggest is you can go and create your notebooks. When you go and do that, you can, well, obviously you can't see the notebooks here. So I will come to the view that is using when you log in. So do you notice that you have these kernels? I put just a starter kernel here. And this starter kernel doesn't have much. It just shows that there is a bit of code and it produces this output. It is a boilerplate kernel that gets created when you hit create new kernel. So obviously I wouldn't put the solution here yet. I want all of you to contribute your files and do that. So any feedback, guys, before we move on? This is a basic homework I expect you to do.
Asaf, before Monday, we have to submit it, right?
Yeah, before Monday, try to have something in, each one of you.
Yeah, okay.
So individual.
Individually. This is an individual project. I am willing to, like, if you want to, if you find too intimidating to do individually, you can do it in pairs. Preferably individually, but if you can't, pair up, because if you feel the learning curve is too steep, pair up with somebody. You have a choice of languages, R and Python for this, and bonus for doing it also in Julia. But then Julia, you won't be able to post here. You'll have to send it to me in Jupyter by email, and I'll be very happy to look at the Julia submissions. If you say, I don't know Python, remember this weekend I'm giving a free introduction to Python for data science. Questions, guys?
We have to use this notebook from Kaggle, or we can use our own Jupyter?
Yeah, what I would suggest is, you can do both ways. See, you can do it first in your Colab, Google, or on your local machine, and then post it here. Right? That is easy to do, or you can create the notebook directly in Kaggle. It's up to you. Generally, the Kaggle platform is quite slow, so it may be much better if you do it locally. I mean, locally means on your either laptop or in your own Jupyter in Google Cloud, and then bring it in here. But I would like to see the submission here eventually, so that everybody can benefit from everybody else's submission. Now, one thing I would suggest, if you do it, in the interest of making sure that others, I mean, see, here's the thing, guys. It's an honor system. No point in just seeing other people submit and just repeating what they have done. I would suggest that try to do it on your own. It's a very simple problem. Try to do it on your own, and once you have done it, then look at other people's notebooks.
When you say submit it here, what does it mean? Like copy paste the code here, or how do you submit it to you?
So for example, here is a notebook, right? Say, here it is, a new notebook.
I see, and save it.
The language, yes, exactly. Show advanced settings. You can do that, and that is it. You can paste your code here. That is one way of doing it. There may also be a way to just directly upload it. See if you guys can find that. That would be good.
Got it, Asif. That's easy enough. Thank you.
So after that, and a lot of these homeworks, I'll put it here for you guys. Your projects will be here. So let me tell you what your project is. The first project is, there are 3 projects that you will have to do. Right? Actually, first, let me finish with the homeworks. This is one homework. The other homework is, there is a data set here called breast cancer data set. Do you see breast cancer prediction, the breast cancer data set? So, Wisconsin data set. So, if you go to this breast cancer data set, and I'll, by the way, put everything in email and post it to Slack and so forth. This is a famous data set. It is also a classifier problem. At this moment, use whatever you know. If you only know logistic regression, first homework is just apply logistic regression and do it. Now, that homework, I wouldn't advise you to post it to this public place, because you may feel awkward. You're making an attempt. So here is what I would suggest. I'm going to clone this data and make it available under the, just like the river data set, under support vectors, AI lab. Right? So once it is available under this, I'll send you guys an email saying, it is available. So post your kernels, not in the public space, but here. Once you have posted it, it's very easy to migrate it later on. If you feel really proud of your kernels, you can always migrate it to the public space, or we can make this space itself public space. Right?
Hey, Asif.
Yes, go ahead.
Hey, the link you sent on the Slack, right, for the reward data set, when you click on it, you go to Kaggle, right, and you're in a signed in page already. Now, how did you get to that new notebook? Where is that link?
I have to add you to this. So as a user, I have to add you to this.
Oh, to this. Okay, then I will get the new notebook link. Okay.
And so, which is why it is important that today, guys, before we finish the class, because today it's all about hands-on, all of you have an account on Kaggle. And as you create account on Kaggle, please put it on our Slack discussion group. As you know, we have a Slack discussion group here, the Data Science 2020. If you don't find your name here, you should be concerned. Let me know, let Prachi know actually. She'll keep adding you to this. But put your Kaggle account here. If it is just your Gmail address, I would highly encourage you to just use your Gmail, then put it there so that I can keep adding you guys as users to this private data set. And then you're ready to get started with your homework. Are we together? So just like that, we'll do the breast cancer data set. And there is a third data set which you will do. It is the California housing data set. Do you see that there's this housing data set for California? So this housing data set, once again, I'll post it onto a private support vectors channel so that your kernels remain your kernels. Now, these two data sets, because they have been heavily studied by others, you may be very tempted to just go and read other people's submissions. I would strongly suggest don't do that yet. First, try to solve it on your own. And then your solution may not be as great as the best solutions, because the people who are highlighting or showcasing their thing, they have worked on it for weeks and weeks to perfect their notebooks, right? That's why they're so high up in the leaderboard and so forth. So you don't have to, because I'm giving you time only till Monday. So you have limited time. Your notebook may not be that great, but the advantage is I'll give you feedback on what you have done and I'll help you improve it. And the whole idea is that by the time you finish this workshop, you will be producing world-class notebooks, right? Or data science notebooks. So this is your third homework. I'll itemize it. So the three homeworks are analyze the river dataset, analyze the breast cancer dataset, California dataset. There are two more data sets actually. One of them is called the flag dataset and other is called the hill dataset. So you will have a total of 5. 3 of them you would not have seen anywhere else except here, because they are support vectors created datasets. Breast cancer and California housing are public datasets. You are going to you can sort of do something and then see how others have done it and so forth. And also in the book here, those of you who did who have access to the ML100, who took ML100, they have access to it. You of course remember that those data sets are heavily studied in my book. Right? The California data set at least is, I don't remember if I added the breast cancer here, but I think I have by now. So both of these data sets are heavily studied in my textbook. So those of you who have taken ML100, of course, have this. Okay. Those of you who are repeating this class would also have analysis of those two things from the past. So, but those of you who are new, of course, you can benefit from the public data sets available. So that's
so Asif, what is the name of this book? It's on your supportvector.com, right?
Yeah, so if you registered for ML100 this time.
Oh, this time, okay. I registered in the past, but okay.
Right. So then you would have had.
Oh, okay.
It's called Data Explorations. Literally, you're seeing the cover of my book.
Oh, okay. Data Explorations.
Right, and you're seeing this book. It will be, I mean, obviously, those of, I mean, hopefully I'll finish it. Those of you who haven't taken my previous course and would nonetheless want to buy a copy of it, I'll be happy to give it to you. But at this moment, it's work in progress. As you can see, it's a draft. I'm trying to finish it within 3-4 weeks now. The first one, then you guys can all buy it. I'm giving it at cost. In other words, I'm not making a profit or anything out of it. Whatever the printer charges, I'll pass it on. The printers charge a lot of money for us for doing color printing, but so be it. Whatever the cost is, I'll let you know. If you want a copy, you can purchase it at price. So, well, that's that. Then there are 3 projects, guys, that we are going to do. The projects are, you will analyze a data set, which is, hang on, archive. Now, the archive data set is a massive data set of, well, this is a smaller data set for natural and physical sciences, acknowledgements. So this contains all the papers that were published in our field of machine learning, right? So what is archive? Would anybody like to mention what archive is?
That where university researchers publish their research and.
That's right. It is not just university. Everybody these days, if you have any new research, you don't wait to publish it in a journal. You instead go and publish it in archive. So to show what I mean by that, let me see. If you want to see what I published many years ago, I would go and search for myself. So these are the 2. And there are other papers I've not posted to archive, but this is an example, right? So there's obviously, well, this is a little outside machine learning, but so it wouldn't mean much. But this is a place where the best research are published. Every time a new research comes, not only best, all research is published. So people have these different fields, and all those fields publish here. And this is heavily studied. Most of the great works are first published here as preprints. For example, this last Sunday, I talked about the paper, Attention is All You Need. If you remember that. Attention is all you need. And that paper is somewhere here. Attention is all you need. Yeah, all you need. Do you see this? This paper is, again, just to give you an idea, it has 8,574 citations. Why? Because in the field of machine learning, especially natural language processing, it was a game changer. The whole field of natural language processing changed right after this paper was published at the end of 2017 and early 2000. From 2018, we do everything differently. Every language translations and summarization and everything is now done using something called transformers, right? So this is the place where you go and find serious work. So what is our work? What we will do is this data set is manageable, 69 MB. You will find, and the project here is, and this project, by the way, you can do in groups of 5. And today I want you to, as you guys are here in the break, form your teams and let me know which are those teams. And in Kaggle, you can go create groups of 5. Huh? So form your team. Let me know what the name of your team is, register it in Kaggle, and your job is, I will explain what it is. This data set, we will analyze from text perspective. We will do descriptive stat, who are the most published authors, who are the most cited authors. We will do basic descriptive statistics, top N. If I ask you, who is the author in these fields, or in each of these fields, who is the most cited? Which paper is the most cited? You realize that those are easy questions to answer, right? You just have to count the citations and so forth. We will start with that and we'll build that project up. We'll make a graph of, citations. This author cites that author and so forth. We'll create a citation network, right? We will also create from paper to paper citations and so forth, network. All of that we'll do, and then we'll do link prediction. Right? So what is the likelihood that this author is going, in his next paper, is going to cite those other authors, those other researchers? So we will do it as a machine learning task. It is all very interesting. And this is a project. As you notice, this project is not something you can do in 3-4 days. It will take you the better part of 6 weeks. Right? So form your teams, get started, and engage with me. I'll be available all the off hours, evenings, nights, weekends, to guide you through your project. How many of you, I hope you guys are not feeling that this is a lot of work. If you feel it's a lot of work, let me know. But this would be one project worth doing, and I'll write the detailed instructions for it. The other project has to do with COVID. We all live in the world of COVID, right? So we need to do the so when we go to the data sets, search for COVID data set. Yeah, and topics data sets. The COVID-19 data set. Now, the big one obviously is from the world challenge, COVID-19 challenge. So we will start with this data set, and I'll give maybe a subset of it. We'll do the same thing. We'll do exploratory data analysis. We'll do all sorts of things on COVID data set. I'll post it as a project. And the last data set that we do. So why is COVID good? It has a lot of things to do, descriptive statistics, modeling, and so forth, making machine learning models. It's a project. The reality of COVID is in front of you. So it will guide you in what to look for in data. You can ask interesting questions in the data and try to answer those questions on your own. It may be that other people have answered those questions. Doesn't matter. You're not trying to make a breakthrough, but you can certainly use these data sets to learn machine learning and techniques. So we'll do that. And the last data set that you will do is something to do with Higgs Boson. So Higgs Boson was, there is this data set. We don't care about the challenge. We only care about this data set. And this data set is also reasonably small, 54 MB. You have to start by doing descriptive statistics, and then we'll make progress beyond that. Don't try to immediately go and start doing a major challenge there. Just start by doing basic descriptive statistics, and then we'll see what we can make out of the data set. I'll guide you guys through it. So guys, are we clear? This week's homework is quite simple. You start with the river, the flag, the hill, the breast cancer, and the California housing data set. Start and do as much as you can based on what you know. It will also help me establish what exactly it is that you know. Right? At what level you are. So for example, if you're just starting out, you may not be able to make much progress. If you have really been in this field for some time, you'll be able to do much more complete analysis. And there are 5 tasks. Pick it. The river is something that you absolutely must do. The other ones, try to finish it. And then the project, of course, you don't have to finish or do anything by this coming week. It is a 6 weeks project. I expect it to be done by end of the 6 weeks. Are we together, guys? Right. So now you can post it at Kaggle, but let's go and see where else we can do your labs, where it is advantageous to do your labs. By the way, whenever you submit your notebooks, people tend to put pretty pictures. You can go to Unsplash, this website called Unsplash. It gives you freely usable images. So you can search for anything. So for example, if you want to look for an image of COVID-19, you can see all sorts of freely posted images of COVID-19. People wearing masks mostly. Those images may not be the best images, but they're reasonably good, I guess, for you to just stick it in your notebook and jazz it up a little bit. Right? So use this website Unsplash if you want. Then the next thing I would like to do is go to Colab. So this one, before we take a break, guys, I want you guys to do along with me. Visit this website called collab.research.google.com, right? Well, because I have some things here. Tell me if you have reached this place. If you are seeing something like this there, all of you. I can't hear you. Please.
Yeah, I see some other notebooks getting pulled in.
Yeah.
Perfectly fine. You
Yeah.
can start with just the basic ones, getting started.
Let's see
Click
it.
on the getting started notebook. What is Colab?
Which notebook,
You
Asif,
mean
here?
welcome to Collaboratory?
Yeah.
Yes, welcome to Colab.
Oh, welcome to Collaboratory. Okay.
Okay.
And when you do that, welcome to Collaboratory, do you see that there is text again and this data sections, right? The data sections are the sections that you can run. These are executable sections. So a notebook is divided into some English text explaining what you're trying to do and then doing it, right? This is an example of some Python code that generates a graph. If you write this code, then you can click on it, right? You don't like the color green. Let me just make it red. Right, and now I click on this. You notice that the graph became red, right? So you can do whatever it is. You can do Indian red. Let's see if it recognizes Indian red. Yeah, the color changed to Indian red and so forth. And you can change the code and you can do all sorts of things in this code. You can do, so first exercise for today is, guys, I want all of you to go and just visit Collaboratory. And obviously those people who have done ML100 and so forth may find it a little bit basic, but let's start with the basics today. Today is the first lab. And what I want to do is study this properly, like study how to code, write new code, just create a new notebook. How would you do a machine learning exercise, for example? There are lots of tutorials. For example, there's a course on introduction to pandas, just as a, as a notebook here. You can learn about pandas just by running through this. So for example, this notebook, if you want to run it, what can you do? You can go and say run all. Or you can run individual segments, and when you run all, these things will start running. Now, as you run your notebook, at the top, you notice something. You can, what all things can you connect to? You can, first of all, this is free. Free is great for the purposes of learning. You can create your notebooks in Colab. You must become familiar with Colab, guys. It's a de facto standard. People use Colab to create their work these days, right? The data science notebooks in Colab. So get used to Colab. Try to, what I would suggest is create your solutions in Colab, and then later on you can go and post it to, some of them to to Kaggle, so that you're familiar with both of them. Now here, do you notice that there is a drop down which says you can connect to a hosted runtime. So in other words, if you have a more powerful machine, you can connect to it, right? At this moment, it just connected to a basic machine. You can connect to a local runtime. One more powerful thing is, if your home workstation is quite powerful, you can actually connect it to your local machine. So for example, here it is, a backend URL. You can start connecting it to your local machine, and so your code will be executed on your local machine. Again, a very powerful thing. You get the benefit of Colab, but you're using your own hardware. rather than using the hardware from Google. So it's very interesting that transparently you can move between local machine and the cloud machine and do your work, right? Makes a difference. And then become familiar with writing things in Colab. Let's get a solution in Colab. So once you have run all of these things in, executed it, you see the results of each of the execution, like for example, of the city, etc., etc. What is pandas? Pandas is the data frame. And we'll talk a little bit about the theory after the break, but Colab is one thing. The other thing that I want you guys to do, so two things. We did Kaggle, we did Colab. The last thing I want you to do, and by the way, this session is recorded, so you can go back and look at it. So is go to Google Console individually, go to your Google Console. Then once you are in your Google Console, let me switch over to Google Console. Then in the Google Console, you can scroll down and you will notice a section called Artificial Intelligence. Do you see that? Do you see, guys, where my mouse is?
Yes.
Intelligence. So when you go to this, there are many things. For example, data labeling, there are data sets and so forth. So here is where you can upload it or keep your data sets and so forth. But then you can go back to the same thing. Where is my artificial intelligence thing? AI platform, right? Under artificial intelligence. Do you notice that there is AI platform has something called, well, let me first go to the dashboard. It may be worth going to the dashboard. When you go to the dashboard, there are many things you can do. There are prediction models and auto ML and all of that. But the only thing that we will use is notebooks, right? So you can create notebooks here. You can go to your AI hub and you can do a lot of things. People have created notebooks and so on and so forth. I would say that your assignment for today and till the end of this week heavily is to just make yourself familiar with these things. It's very important that you do. This is a whole lot of new information for many of you. For most of you, I would imagine. Become familiar, like, know the lay of the land so that you don't feel so lost. It's a vast space. You can't pick all of it up in a day, right? So, but you don't have to. You don't really have to pick all of that in just one day. And let me just take a particular thing. And then you can go to your notebooks in your AI platform dashboard. You can go to your notebook and see, you can create a notebook instance. Do you see this, guys, at the top? You can create a new notebook instance.
Mm-hmm.
Yeah.
Now remember, Colab is free. It's important. Colab is free, but when you create a notebook here, you have to be careful. This can get you into a lot of bills. And so remember to stop it. So here you see, you can do R here, right? Along with Python, scikit-learn, etc. You can do a Python 2 and 3. You can do your TensorFlow, 1.5, TensorFlow 2.1, 2.2, Pytorch, right? Generally, what I advise you to do is pick between one or the other. Pick either. My feeling is, if I have to give you an advice, I would say pick Pytorch, because it contains everything for Python that we need. It contains scikit-learn, pandas, NLTK. And in this workshop, we will just touch a little bit of Pytorch. You can do it with GPU. GPUs make your code run faster, or without it. I would say without GPU in the beginning. For a large part of this workshop, you won't need the GPUs. You need the GPU for the next workshop. So you can go, let's say, without GPU, right? So I can say Pytorch test notebook. Yeah. pick a region for this. Now comes the interesting part. You can change, you can customize it. Don't do it right now. Start with very basic at this moment. But if you customize it, you go to a page where you can control just about everything about it. So for example, you can pick what sort of machines you need. For example, you can take high CPU machine, right? You can go with, as an example, you can go up to 96 vCPUs and 86 gigs of RAM. If you were to select something like this, you realize here, it tells you what bill you'll incur if you leave this notebook running forever. You don't shut it down.
Wow.
Right? So this is the danger. Don't do that. But just below that, you see the price per hour, $2.38. That is not much of a price to pay if all you're using it is for half an hour. Suppose you have a big computation and you get tired of running it on your collab or on your local laptop. You feel that you're wasting hours and hours doing it. One thing you can do, you can suddenly go reserve a big instance like this, run it on that. Most likely your computation will finish in 15 minutes. So long as you remember to shut it down for 15 minutes, how much will you pay? Maybe 50, 60 cents for the computation, isn't it? Now paying 50, 60 cents is not a big deal at all, right? You can pay it and you got the results in your notebook. And once the results are there, those results don't disappear. The output is there in your notebook, right? But the worst thing you can do is reserve a huge notebook like this, like a huge machine, and run it for a notebook, and then not really do anything, just go to sleep, and a few weeks later realize that your instance is still running. Don't do that. You'll end up creating a huge bill for yourself. So that is the danger that I would say. On the other hand, if you are the kind who says that, why not take a small machine dedicated to me, let it run all the time, I don't care. You can go with something like this, take this like 8 or 15 gigs of RAM. I wouldn't take that. Actually, I would take a standard, let me see by default, what was it? Machine type. You can go with N1 standard 4 CPU. The N1 standard 4, if you look at it, it's $100 a month, right? Again, even if you forget to shut it down, the worst that you will do is pay $100 a month, right? But hopefully you'll remember to shut it down when you're not using it. So you can do something like that. Are we together? Right? So when you create a machine like this, see what happens. You created a machine like this.
Asif.
Yes.
Just one question. So just to get an idea, right? So the other one you said it will take most probably 15 minutes. So this one, if you take, how much you said? How much time typically?
See, for the sort of things we'll do in our lab work, you will write the notebook and you'll run it. See, you'll write the code for quite some time and then you'll run it. We are using those things only to run it. Maybe half an hour or something like that here and there. At the end of the day, if you're careful, you'll get a like $4 bill at the end of the month.
That is for the high power one, the 96 one.
No, for this one.
Oh, for this one, okay.
If
the
you
standard
keep it
one.
all the time, you'll pay $100 a month. But most of the people from experience, right, when they write their code, it costs them like they end up with a bill of $4, $8, $12, $15 per month.
Okay.
Very low bill. Because even if you're coding straight here, see, the advantage of this is it's a bit more powerful than your collab, basic collab. So
can you run collab from here, or you have to bring collab copy paste here or something?
There is a way to do that.
Okay. You don't have to go into that. I mean,
yeah,
we'll research it here. Yeah, thank you.
It's a complicated way, but we'll go.
Okay.
I don't know why at this moment Google hasn't solved the problem, but they're trying to. I mean, I'm sure they'll bridge it over. Right? So see, here's the thing. I have this. At this moment, have I started this instance? I have not started this instance, isn't it? It is just allocated. I have not given it any GPUs, right?
Right.
If I want to give it a GPU, this. So it is, sorry, this is live at this moment. What do I do if I want to stop it?
Select that and then stop it.
Right, exactly. I can go in there, and then if I go here, dismiss, fail to get the server root, etc., etc. In the beginning, it will create some things like that. What do you want to do? You want to create a notebook? Let's go ahead, and there's some tutorials. Here's a notebook. There you go. You have a notebook. You can change the name of the notebook, right? And you can get started. So suppose you say import numpy np, right? And then import. These are the basic imports you'll do. Pandas as pd, right? Import matplot lib.py plot as PLT. Let's do something. X is equal to np dot there you go. You notice that you ended up running some codes and so on and so forth. You want to then, what do you want to do? Let's go rename this. Let's call it starter notebook. You have it here. Now you can do some basic things. You can, one thing that I would suggest is your notebooks, you should commit it to Git or somewhere so that you don't lose your work. It's always a basic good idea. Then you can do shutdown. What did I do? I shut down this notebook. Right? I can go back here. All my sessions are terminated. Right? I can go here, and so this is it. I can go back to my notebooks if I were to refresh this, and then
You were using Pytorch there, Pytorch, or that was
Pytorch. Pytorch is something we'll use for our deep neural networks.
Okay.
So suppose I do, and this label, you can add all sorts of labels, etc. You can stop it. This is the most important thing. Once you're done, you stopped it, right? So now we have used this notebook for a few minutes. I'm sure I will get some bill for this, but it will be in cents.
So Asif, one question I have. So in this case, you went there and you wrote actual code, but in real world, what will happen is there a way to kind of copy paste from somewhere?
Oh, yes, definitely.
Right? That's what we'll most probably do, because we'll write the code outside, right?
Yeah, you do it outside. And in fact, depends upon how deep you go. See, at this moment, you guys are in the learning phase, so you can write your code here. Once you start writing a lot of code, it is much more customary. Let me see. See, this Windows machine I use only for teaching, so it may not have this Oh yeah, here it is, Pycharm Professional. So usually what I do is write elaborate code in Pycharm, then copy paste it here. Of my licenses.
So Pycharm is Anaconda, right? Is it?
No. Pycharm is a.
Oh, Pycharm is different.
You have to pay for it. So it's a let me show you what Pycharm is if you guys are interested. Pycharm. This is Pycharm Ide. It helps you. It's just a elegant, it's just a full-fledged code development environment, integrated development environment.
Oh, it's an IDE for Python.
Okay. Yeah. So Abhijit, think of it as the J developer for Python.
Oh, okay. But will you be able to import all the libraries and everything will be there? You can.
Oh, yes. So see, what happens is once you become good at it and you're writing a lot of code, you write it as libraries, and then you bring your libraries into your Jupyter notebook, right? You don't pollute your Jupyter notebook with very complicated Python code. You keep it outside as libraries or as Python scripts, Python classes and files or modules, and then you just use them in your Jupyter notebooks. So guys, let me recap before we take a break. What are the things we learned about from basics? We learned about Kaggle. We are going to take Kaggle seriously. There's a river dataset I've posted. I want all of you to come give me your email so that I can add you guys all here. It's important that you put that on Slack. The second thing we learned about is Colab. This is Colab. Your assignment today, actually the last hour, I won't be teaching. I'll just be there to field questions as you guys try this out. I want you guys to try all this out before you go get off this session. Go to Colab, make yourself familiar. See, try to run this, right? Overview, like this thing. See what happens when you run this. For example, you see the run button here, right? Do that. You must become familiar with Colab. By the way, do you notice I have these little dogs running down? That you may not have. That is just some for fun stuff. You can do this. By the way, you can theme it also. Do you see I have a theme adaptive? You may prefer a light theme. If you do a light theme, now the whole page has become light colored, right? You can do this Colab Pro. So you can go get more runtime, more memory, and so on and so forth. Right? And so that is one. But remember, guys, now you're talking about paying money. So before you try to go and start paying them money, don't do it. For most of this workshop, you don't need it. Only for the projects that you guys are doing as a group, you need it. And you can share. Suppose your total bill comes out to be $25. 5 of you doing the project together can share the $5 amongst yourself. But don't waste money thinking that you can reserve a very powerful machine, and because of that, your code will run much better. Sometimes it will run at the same speed because a lot of the homeworks that we are doing are simple homeworks. Are we together? Right. The editor. And you can change a lot of things here. As you can see the indentation guide, code folding in the editor, so forth. How much indentation you like. Some people like an indentation of 2, some like it of 4. A vertical rule, 80 is the default. These days, more like people go with 120. So you can put 120 here. What kind of a key binding do you like? Do you prefer default VIM? Those of you who are used to VIM, you can type as though it is VIM and so forth. You can do all of these things, and this again, you can do your GitHub and other things, and miscellaneous. This is, remember, this Koji mode is where I enable dogs. If you put kittens also, now kitty will also start showing. It's just a fun thing. It's a joke.
Hopefully they are not charging for it.
Yeah, no. So long as you stay away from the Colab Pro mode, you're not. Okay. If you start going to the Colab Pro, then you, and of course you can share these notebooks with each other. You can take each other's help. Are we together? Font size. Actually, one thing I realized that the customizability is very limited. You can't change the font and other things. The theming is also fairly basic, but for what it is there. If you want to go pro,
Yeah.
here it is. You can upgrade to $10 a month. I would say that before you start reserving your own Jupyter notebooks on massively powerful machines, go the simpler route. Just pay $10 a month. See if that works. If that also doesn't work, then you can keep on upgrading to more and more. Are we together?
In this one, Asif and Colab Pro, not sure if you have used it. The output of notebook can be a Word document, or is that always PDF?
Oh, no.
Can I print it out?
Yeah, we can try that. So it depends upon it. Let's go and do it. Suppose I have this, right?
Save as HTML.
Yeah, I go here and I say, save a copy in GitHub, etc., etc. Download IPython notebook, right? So I can download this IPython notebook. Now I can run it in my local Jupyter.
Okay, that's the way to do it.
And
Okay.
this is upload notebook. If you have done something locally or you have done it in your other fancy machine that you reserved in the cloud, then you can upload, bring it into Colab and so forth, open notebook and so forth. So bring this down, and then of course you can do everything.
Okay, got it. Thank you.
So guys, I'm going to take a small break of 5-10 minutes. In this, and after that, I'll just give an hour to field your question. Today, we are not doing any real lab. Next week, of course, I will walk through the solutions of those exercises. We'll take a break. After that, I'll field questions. And then I will start walking through libraries. Today, I'll walk through Pandas and Scikit-learn for Python.
Asif?
Mm-hmm.
Before we end the session today, will it be possible for you to summarize again, like what exactly are the assignments and what all we have to do?
Oh yeah, sure, definitely. I'll do that.
Okay, thank you.
All right, guys, let's take a 5 minutes break, 10 minutes break, and I'll be back. Would you prefer doing it all locally?
I'll rather do some mix and match, Asif, just to get a hands-on, right? Use some of the local. I like that idea where you can use your local host and still use the company. So.
Yeah, so then you benefit from the Collab notebook. Collab notebook is generally considered improvement upon Jupyter because it gives you auto completions much better. Right. So for example, let me do that. Suppose I go to the bottom and you want to add a code section. Let's say at the very top, you want to add a code section, right? So suppose I do import numpy. Do you see that? It is giving you auto completions, and so
yes,
it's doing import mat.lib as pyplot. So most of the statements you get auto completion in pandas, right? As PD, right? And then it keeps giving you, these are the things you would use. Pandas profiling. Pandas profiling you would remember from the ML100, the intro to ML. Yeah. So we have all of this. So suppose you start saying x is equal to np.
Do I have to download this library again and again every time I start a notebook, or
which library?
Oh, the NumPy and MATLAB.
Yes. Okay. No, you just have it once imported in your thing. After that, you see your collab will stop after 24 hours.
Right, I see.
I think then you just have to rerun it, but you don't have to download or anything. Nothing to download here.
I see. Import, when you say import, right? Do I have to import it again and again every time I write a new notebook, or?
Yeah. Every new notebook you have to do import for sure.
Okay.
Asif?
Right.
Asif?
Yeah, go ahead.
Yeah, can you let Kamya in? I think I've lost the permissions to grant entry.
Let me certainly do that. Let me see, where is that Kamya? Oh, there is no waiting room. She should already be in there.
I'll ask her to try again.
By the way, do ask her to also send me her phone number.
Yeah.
I tried to reach her dad, Ram. I couldn't today. His number has changed.
Yeah.
So has she been able to join now?
Don't know. I've told her to try again.
Should I enable meeting room? You have enabled the waiting room. And I'll make you, Prachi.
Yeah.
Once again, what do I need to do? Make
host.
Host. Where do I do that from?
From the settings, view options.
Okay, let me stop sharing my desktop so I can see the whole UI properly. More. Okay. Make as host. All right, I made you the host again, and now you can do all that is necessary.
Yeah.
Okay. Asif, Prachi, it was mentioned that, Asif, you mentioned you wanted to see everyone's emails. is there a Slack channel, specific Slack channel you want us to type our
Yeah, Data Science
emails?
2020. Data Science
Yes.
2020 is it.
Oh, okay.
And so let me go
Oh, I
monitor.
see. A lot of people have done that.
I've done that. I've just-
That is for the Slack that Kaggle purposes, right? You just want email address. Okay.
Asif, why do we need email addresses to add in Kaggle? Like, I suppose you can still view the data sets, right?
No, not really. This data set is private.
Oh, okay.
See, the whole idea is that this particular notebooks, at this moment, you may not feel comfortable exposing your notebook till you feel it is polished, which is why I've created some privacy here.
Okay.
So,
Got it. Thanks, Asif.
so guys, I know that this is a hassle compared to doing it on the laptop. Doing it in the cloud, it's a bit of a hassle. Doing it in Kaggle and all of that collab. But believe me, this is the future.
Yeah.
Yes.
So we need to move with the practical times. By the way, I'll also give today, if you want, we can give some time to setting it up locally. But maybe I'll do that. I'll help you set it up locally also. In the next few minutes, I'll give those instructions. So, kernels. Okay, guys, I'll get started now. Let me share. Are we all back? I hope we are. Let me start sharing my screen again. Oh, host disabled participant screen sharing. Raji, you'll have to give me the yes. It's still disabled.
Yeah, I am just checking where can I give you back the permissions.
So guys, remember that on Sunday, there's a free session on word embedding. After that, there's a free session on Python for those of you who want some experience in doing notebooks in Python and getting started with Jupyter and so forth. And after that, I'll keep some time open so you can ask for any help you want. So all of Sunday afternoon, I'll be available for that.
Asif, in the support section, can you request for control again? I suppose it should work.
Oh. Let me see, recording live on YouTube. View streaming on YouTube, copy, speaker view.
Who can share is only host. So should I do it all participants?
All participants, yeah, make it.
Okay, yeah, done.
Done, okay.
Yeah.
So now I'll try to share the screen.
So Asif, what time is a session on Sunday?
It starts at noon.
Okay.
So let me write it down so all of you can have these things with clarity. So what we have talked so far is this. Homework. All of these things, I'll send it to you by email. I will send instruction. Actually, it may not be email, but I'll put it on Slack at least. Email. What we have is the river dataset on Kaggle. Likewise, there is a flag dataset. There is the hill dataset. Hill dataset. These two are classifications. This is regression exercise. Then we have, then two publicly available datasets are Wisconsin, breast cancer dataset. It's a famous dataset. In your career, at some point, you have to analyze it. Dataset. And California housing dataset. California housing. And so this is your homework, guys. Huh? Now, you may not be, based on your level of expertise, you may not be able to do all of it. If you are able to do all of it, that's most wonderful. But I would say that at least do this one. Try to do this one. And then try to do this one. And then if you do this one, the second one becomes easy. These ones become easier, but pace yourself out. Huh? Then the instruction is that do it in Colab, Kaggle, Jupyter, etc. You can do it in R or Python. R or Python. Is there anybody in this group who would rather do it with Julia? Any Julia enthusiasts here?
I would want to try it.
I might look into
Might
it. I
give
haven't
it
done
a
it yet.
try. Yeah.
I'm sorry, who said yes?
Me, Kate, and Dennis. We might give it a try. Prachi,
Okay.
Kate, and Dennis.
Right, sure, definitely give it a try.
Wish us luck.
So this is it, R or Python. And if you have time, if you're highly dedicated or motivated, both. Do it in both, because if you do it in both, you'll have a lot of learning. It also means that you won't have much of a life from now till Monday. You'll be busy. So this is your homework. What is your project? Project is not due now. At this moment, the only deliverable is form teams. Forms teams less than equal to five members. Now, guys, is there any teams that have formed so far? If not, I would strongly advise you that form the teams and come back to me and give me the list of team members. So for each team, pick a name, pick a name and mascot. Right? The name could be, I don't know, tiger or whatever it is. Tiger, and you can have a picture of a tiger. Whatever it is. Pick your name and mascot, tigers, or something like that. This is it. And then look into COVID-19, Higgs Boson, the Higgs Boson and the archive. These three data sets, they will form the context of your project. So these are biggish things. You have 6 weeks to deliver on it by end of the workshop. 6 weeks to deliver on the project. Now, one thing I will give you guys in return, if you put in the hard work, you do the homeworks, and you deliver on a solid project, I will be willing to be your job reference. Usually, I'm not willing to be the job reference. I do it only if I know that there is proven competency. So you do all of this, you would have developed proven competency. I will help you. So that's the project. There will be a quiz on, we haven't taught much, but if you want to just check if you remember your basics, quiz on the basics of ML. It's an optional session. You can attend or skip it as you wish, optional session. So I'm going to hold this quiz sometime on Saturday afternoon. And I'll send out a notification to that. Those of you who are interested, come there. This is all part of the interview preparation. Right. If you can, do come by. Are we together? Guys, some of you may need to mute yourself. I can hear you typing. So it's all, I suppose, getting recorded.
So, Asif, the interview prep is the Saturday afternoon, right?
It's Saturday afternoon. So I'm giving you sessions on Saturday, one session on Saturday afternoon, and 2 sessions on Sunday afternoon.
Sure.
All of those are optional, and anytime you can reach out to me if you're getting stuck with your collab and so on and so forth. Are we together? Okay. Now what I would like to do is walk you through one particular library, Scikit Learn in Python. Next time around, maybe I'll walk over our libraries and so forth. But at this moment, I will do a particular Python library and show you what it offers. Today is very general, guys. We are not walking over the labs. We are not doing solutions and so forth. It's because I'm setting the framework for you guys to do enough lab before we start walking through solutions and code walkthroughs, practical code walkthroughs. Also, we haven't done enough theory. So I'm just this week was just getting people started. So in that spirit, let me now go and share the main screen again. So in machine learning, there are a few libraries which are very important. Most of those libraries I have mentioned. Actually, those of you who already have access to my book from the first workshop know that I mentioned at the end of it, I've given a pretty long bibliography. But here, what I'll do is I will just walk through some of them. So Scikit Learn,
Yeah, Asif.
something you'll use for the rest of this class.
Yeah, Asif.
Yes, go ahead.
So for this Jupyter notebook, do we have to install that Pycharm or Anaconda?
Oh, no, you don't have to do that. Anaconda. So, okay, all right. Why don't we start with that? If you're locally doing your homeworks, see, if you're doing it in the cloud, Abhijit, you don't need to install anything. Those
cloud like in
come with
Colab?
everything installed. Colab comes with that built in.
Oh, yeah, okay. That's fine. That's fine then.
But if you want to do a local install, then what you would do is you would go to anaconda.org on your local laptop. It's still a good idea to install it locally also. Go download Anaconda. Do you see this Anaconda, your data space?
Yeah.
Download this. I will do it right here. Actually, why don't I do it and show how to do it? So this is Python version 3.7 for Windows. This machine from which I'm presenting is Windows. Now, usually I work from Linux. So when I'm walking you guys through the solution, I might be on the Linux machine. So, but for all the 3 major operating systems, you have this here. It's very slow. It says 1.4 MB out of 366. Yes. For whatever reason, it's downloading very, very slowly at this moment. But it's a one-click install. Once you
yeah.
Just
I have already installed it. I was just asking.
Right. And when you do that, I'll show you what it looks like. And once you have installed it, it will open up a shell, something like this. Python is very slow, as you can imagine. There we go. So what you do is you either pick Jupyter Lab or Jupyter. I would say in the beginning, start with just Jupyter Notebook. Launch it. When you do it, you'll be in a situation like this. You can go there and you can sort of start creating kernels or so-called notebooks. Notebooks are often called kernels. You can do that. For example, I'll take a note. Well, this is code. You can write code or you can write notebooks. Let me take a basic one and we can look into that. Not even this. Let me take Python classifiers. Here it is. So when you do, it is again the same thing. Everywhere you have notebooks, you do the imports, you take in data, you run the data, right? You do some basic analysis and so forth. So these things, those of you who are not familiar with Python, I'll get you a walkthrough over the weekend. Just wait for that. Most of you may be familiar, or in fact, you're coming from your ML100. Most of you have taken that. So I don't want to waste time here repeating all this. Does this all look familiar to you guys? Anybody would like to say that? This is the classifier dataset, one of the classifier datasets.
Yeah.
Yep.
Right, so this is it. So there we go. We won't go into that more. So this is the way to do it locally. Now, this Anaconda environment also gives you some other good things. It gives you the R Studio to write your code in R. So for example, if I were to start this, actually, so on this machine, because I use it only for teaching, most of the things may not be properly set up. I'll leave it. Then you have Spider. Spider is sort of like the R Studio for Python. Once again, you can write your code here. So these are all the different development environments you would use. But these days, by and large, the mind share is taken by notebooks, Jupyter or Colab notebooks, and Pycharm. If you want to do CS work, you do it in Pycharm. Long bits of programming in Pycharm. Okay? So this is it. This is how you would do it locally. Now, if you're doing R, I would suggest that instead of using the Anaconda's R, you should go and get R language, R installed directly. Sorry. Let's go here, R language. If you do this, data cab, oh goodness, it's advertisement, R project. You can go download it. It's very easy here. You can pick any one of them. Download for Windows. These are auto install situations. Nothing very complicated. Base. Download this. You can imagine that it will start downloading it. And let me go through the R installation for a moment. If you do that, it's a straightforward install. You don't have to do anything. Just click through your way. Create a desktop, quick launch starter. So once you install R, By the way, those of you who are interested in getting a copy of the book, I already have a list of some people who showed interest. The new ones who have joined or who haven't signed up for getting a copy of the book, just drop me a line that you are interested. Either Slack or send it to me by email and I'll do that. Then you go to RStudio, which these days is owned by Microsoft. And you can go here. Once again, it's free. You can click on that. Obviously, get the free one. Don't get an expensive something that you don't need. For development purpose, the free one is good enough. Once again, just download the RStudio, and I'll go through the install for a moment.
And the versions don't matter, right? You get the latest.
You always run the latest. And if you do that, where is it? Yes. R generally tends to be much faster than Python, so this should run through pretty quickly. The RStudio, I mean, tends to come up faster than the Anaconda comes up.
Mr. Asif?
Go ahead with it.
Is Pytorch a part of Anaconda too?
No. Well, okay, you can see Pytorch is a library. Once you're in Anaconda, you can select and install it optionally.
I see.
So,
like a NumPy and any other library.
Exactly, like anything. So
I got it.
Your environments in this, install.
I got it.
And so all you have to do is check for Pytorch.
Okay.
Pytorch. It's not installed, so it means that all you have to do is go get it. So you see that Pytorch. All you have to do is click it and go ahead and install it.
It's not a notebook. It's a library.
It's a library. It's just a library. That's
Thank you.
So, and then when you install the RStudio, you can bring it up. Yes. And you can create a new notebook. So I'll create a simple notebook in R notebook, or R Markdown, you call it typically. And it's creating one. And the first time you run it, it will go install a few things. So guys, have a local setup, both of R and Python and Julia, and I'll show you how to do it for Julia also in a moment. So suppose you create a document. You can do your presentation or document or whatever you like. You can even create Beamer slides directly from that. But yeah.
Oh, wow, they have PowerPoint now. Wow, that's good.
Yeah, preview requires installation. So suppose you have PowerPoint in your machine, you can do that. Say, we have done that. So what it will do is it will create a sample little notebook for you here. And all you need to do is just run it. So run all. Once you run it, you see the output right here. So now do you notice that your output is right there in your notebook? And then you want to export it, let's say here. You want to export it to PowerPoint. You say knit to PowerPoint. Let's see what happens. File name, let me just say. Oh, sorry. First of all, we need to save this file itself. Save as save as example. It's an example notebook. I save this file, then I say net to PowerPoint. Ah, look at it. Your PowerPoint is produced. Do you see this, guys? This is a PowerPoint. And you can go into the presentation mode. Are you guys able to see my screen with the PowerPoint?
Yeah.
Yeah.
Yes, awesome.
Yeah.
Slide.
Yeah,
And
looks
then
good.
there you go. Even your graphs show up automatically in your PowerPoint. So these environments of data science are very powerful these days. You can see how powerful it is. Now, suppose I want to instead, if I'm the kind of person who likes the PDF part and LaTeX style, once again, you'll see that it will come up. Well, on this machine, LaTeX is not installed, I think. So it won't work out. LaTeX failed to compile because we have not installed LaTeX. Let me try to do it to Slidey. This is a web format of doing PowerPoints. Some of you are familiar with that, Slidey. So here it is, a pure web native presentation. Those of you who are familiar with Slidey know this. So this is it. You could from there also export it to knit to HTML IO slides. That I'm not familiar with, but I'll learn something. There it is.
it. This is so powerful and free.
It's very powerful. These things are extremely powerful. Do you notice that
Yeah,
you can create an entire web presentation just like that? And the maturity of the tools is just amazing actually these days. The nice way that these tools work. It's really entering a new tradition. You know, data science is wonderful these days. It's really the golden age of data science. The data is plentiful. Applications are plentiful. As far as I can see, almost all AI companies are becoming, startups are becoming successful. Literally, the moment you put AI or something like that, people are ready to find you these days. And it's a wonderful subject to learn from. So guys, this is that. Now what I would like to do in the second part is walk you through this key library, which is the scikit-learn. Library. So one thing that you should start studying is this scikit-learn library. Scikit is the machine learning library in Python. R comes fortunately with the whole thing built in. So you don't need an external library. Now, we will take classification because I've given you a classification task in the river data. Suppose you go to classification. Do you notice that for classification, you have so many algorithms here?
Yes.
Right. Where am I? Logistic regression, it's a classifier. Right. I can go with that. Support vector machines will give you classification. Do you notice that for every large algorithm, so this is the names, what you see in bold are the names of algorithms. So linear models are linear things. If you want to look for classification, paradoxically, the classifier has the word regression built in, which is misleading. So this is your logistic regression. If you click on this, this is what I've asked you to do. You go to the documentation, then some of the math, the way they put it is very succinct. It's meant for people who have taken theoretical machine learning courses. You can ignore all this. To understand it, you don't need all of this in the beginning. You can go directly and straight away go to your, what you need, examples. Do you see how to use this? So you just go straight to the examples and the documentation. So for example, I would go to logistic.
Very good.
Yeah, here we go. This is the section on logistic regression. And suppose I want to see it with examples. I can see these things with examples. It will also tell you which books to go and read. You can go click on this. And there is a lot of code examples that are given here. Do you see these code examples? And not only are the code examples given, You can download these examples. They're usually very well-written code. You can launch it on something called Binder. Binder is another magical thing that you have. It will spin up a Docker instance on the Binder website. So, for example, here it is doing that. And amazing thing is, it is all just free. Here we go. This entire thing showed up, right, on the web. Do you see that? This is a Jupyter notebook that has showed up on the web, right? And so the sample code are all ready to run. I can just go and click on run. Do you see this? Now it is running and the results are right here in front of you.
Beautiful.
So the level of documentation and help that you get in data science libraries is unparalleled. I've not seen it there for normal computer science at all. Most libraries are poorly documented and very poorly done, frankly. So this is it. You
How
can.
do these guys make money? Binder guys.
Yeah, I mean, at this moment you are running it for free, but they hope that you will use the Binder functionality. Right? So if you go to binder.org, let me just go to binder.org. Oh, sorry, not this. What was the address? Notebook. Okay, Binder. No, I went to the wrong website. Binder. No. That itself is not very good. Binder file. My Binder. Okay. Jupyter Notebook. My Binder. Okay. Let's go to mybinder.org. Yeah, turn a Git repository into. So what you can do is you can just point it to your Git repository, and it will convert it into a lovely notebook that you can execute straight on the web like this, right? So all these examples, for example, a plot logistic thing.
Beautiful.
All you have to do is just go run the code. Do you see? You ran the example code that you found on the web, and it just runs it. You can do any one of these code examples that you find in scikit-learn. You can learn, and so you learn how to do this beautiful visualizations, and you quite often use the code because the creators of those libraries have thoughtfully created examples, made sure that those examples are best practices, and you could directly just sort of look at the code, take it from there, and adapt it to your use. And that is how you pick up this field. Very rapidly you can learn this field if you follow these examples. It's just amazing. Scikit-learn. I'll go back to it, scikit-learn. And so the point that I'm mentioning it is, and for regression, let's say that you want to do regression. Here we go. So for any of these, now what I want to do is, I haven't taught you these algorithms. We haven't done the nearest neighbor. We haven't done support vector machines. We haven't done a lot of these things, decision trees, ensemble. All of these things we'll do in this workshop, in the theory part of it. But my point is, see if you can start using it in practice, even before you master the theory. And you can. So for example, to classify the river dataset using a decision tree, what could you do? You can just go to the classification example. You see it here. And you notice that to use it is just 2 lines of code. I hope you can see that, guys. That you instantiate the classifier and you ask, and you try to fit it to the data. And once you have fit it to the data, you can see the entire decision tree emerge on that. Are we seeing, guys, how easy it is to be able to use these things? And the whole question is that, isn't it dangerous to use algorithms without knowing? It is indeed. It is much better we understand it properly, but that's the purpose of this workshop. You start using it, and then in the theory part, we'll understand each of these things. And so, for example, you can use random forests are very popular these days. What does it take to do random forest? Exactly 2 lines of code, and you can do it. So use this to do your homework for this weekend, guys. Are you seeing this, how easy it is? You just go to the list and pick something up. Wherever you see, in every major algorithm, you will see classifier there, right? Multi-class and multi-level algorithm. Then you can go to pick something, a naive bias, Gaussian naive bias, etc. All right, you can go do that. How would you do it? Here we go. And the theory may look a little bit intimidating, but the whole point is we are going to do the theory also as part of this workshop. Right? So get started, guys. And I would say that at least if you want to try it out, use the naive bias, decision tree, random forest, the gradient boosting, support vector machines, all of these, just start using k nearest neighbors. And the only thing I would say don't bother using is the neural networks of scikit-learn. The scikit-learn's neural networks is not used in practice because it's very primitive. It doesn't use the GPU. Right? At this moment, it's a very primitive implementation. We will do that in Pytorch.
Okay.
So that is it, guys. I'll now open up to questions. And reach out to me as you need help through the week. But on Monday, do come back with your notebooks, right? In Google Colab or in this. And in Colab, if you feel like it, pay that $10 a month and get the Colab Pro. It will make your life a little bit easier. Things run faster. Then when the workshop is over in 1.5 months, you can just stop it. Any questions, guys? Do you guys feel now that you have a good idea how to get started?
Yes.
Yes. The data set that we're going to share.
Come again? I can't hear you. It's very dim.
The data sets, can you hear me now?
Yes.
The data sets that you're going to share, we'll see that in Kaggle, right? Once
Kaggle, yeah.
Yes. I'll send you the links to all of them after tonight. By tomorrow morning, I'll send you detailed links to all of them.
Okay.
In the meanwhile, if you want to give some time today, make yourself familiar with all of this, Colab and Kaggle and so forth. Make sure you can log into Kaggle. Then go create your accounts in Kaggle. Then let me know your ID and I'll keep adding you guys.
Yeah, so in Anaconda, if you have to install that package, right, where you showed in that environment tab.
Yes.
Is that you have to sign in to install the package? Or maybe I'm missing a...
No, you don't have to
missing
sign
an
in.
action.
I don't know. It says sign in, but I don't usually sign in. I just go and, oh yeah, this is very interesting.
So when you entered that, you got that list. For me, I'm not getting this list below. Or the list, okay.
See here, you see the environment. Okay, see on this laptop, no, I've not set up the whole environment properly. Maybe I'll show it to you on the Linux. Right? If you guys have time. Or maybe on this Saturday, no, I'll walk you.
Yeah, that's fine.
This machine is just for teaching, so it's not really powered for data.
Okay. Yeah, that's fine.
So we'll do that. Yeah. Anything else, guys?
Yeah. Lasik, just a quick question. If you go to that scikit-learn, right?
Yeah. Website.
Oh, the website you had opened.
Before you go there, just in Anaconda Navigator itself, if you go to the learning section, you will see all this enormous amounts of resources for learning things here. Do you see all of these
yes,
documentations and videos and trainings and whatnot, right? That you can do. Of course, not to mention that Coursera, Udemy, etc., are filled with a lot of helpful hints. The only thing is that they end up eating a lot of your time. So my own personal favorite has been that I spend more time reading a book and trying to code it myself. And I refer to videos only if I hear that some video is very good and I need to refer to it. Generally, I'll do it. So now, what was the question that you asked?
So, Asif, right? Maybe it's a basic question. Let's say go to logistic regression, right?
Logistic regression.
For example, like it can be supervised or unsupervised.
No, no,
or
no. Logistic regression is always a supervised learning.
And where is supervision part in that?
Supervised learning just means that there is a target variable. It's a prediction. That word is very misleading. Supervised learning simply means that it's a classifiers and regressors are both supervised learning because you make a prediction on a target variable. Clustering is an example of unsupervised learning. There is no target variable. You just look for clusters.
Look for clusters. So my okay, and that's confusing because I thought that, okay, there's a way to train it by your supervision, the regression, logistic.
No. A lot of people think that actually, the terminology, that's why I hate that supervised, unsupervised language, because it makes it appear as though the supervised algorithms are not as powerful as unsupervised, which can learn on their own. It's not like
Yes, yes. Okay. Yeah, thanks for that clarification.
Asif, regarding the data sets, you mentioned that river data set is classification.
River, louder please. River data set is
classification.
Yeah, river data set and the flag data set will be classification. Hill will be regression. Breast cancer is classification, and California housing is regression. And so guys, it's a lot. I'm not saying that you'll be able to do all of it. Pick and choose which one you want to play with in the homework. If you can do all of them, that's really good. For those of you who have been doing workshops with me, I would like to see you do all of it because I have trained you to that level. If you are joining my workshops without doing other things, then you will need help. Do at least one, definitely one, if possible more. Do one in regression and one in classification as a minimum. Okay. And get into the habit of using the web, the cloud technologies like Kaggle, like Google Cloud Platform and so forth. At the end of this workshop, what I would like to see is each one of you have a fairly respectable, see each of these homeworks that you're doing with me, it isn't that you're just doing these homeworks to learn. If you do it well, you can show it in your interviews. That's how past students have got jobs. They would literally show their notebooks in their interviews, and that's how they would get jobs. So there is a lot of value to that. Doing it well is your ticket to a good job at a good company. All right, guys, I'm done. Any other questions?
Can you, Asif, can you just show us some Julia part as well? Like.
Oh, yes. Thank you for reminding me. Julia. So Julia. Julia language. So this is Julia. Let me actually do it because this laptop is new. I don't have anything installed, so we can go through the process of installing it. Let us install the latest one. Here we go. You download it, just as simple. We'll install Julia. And Julia, by the way, is the fastest of all this between R and Python. Both of them, it beats by a factor of 10 to 1,000 sometimes. Sometimes it's 10 times faster, sometimes 100 times faster, sometimes 1,000 times faster. It's just amazing. But it's a young language. They're not, the ecosystem of libraries are like 3,000 libraries, whereas the ecosystem for libraries for R and Python will be like 50,000, 100,000 or something like that. So we have installed Julia. Julia comes with extensive documentation, as you can see, again, in the tradition of it getting started. How do we get started? you can just bring up Julia. Do you see this Julia shell? Right. You can treat the Julia shell for just that. So suppose you want to say X or 10, you can just use it as a calculator to begin with, and then gradually build your way through it. And you can follow this. There's a lot of documentation here. How do you declare variables? So actually, let me do this basic. I would suggest that just follow the documentation. It will take you about 4 to 5 hours to become comfortable with Julia and start doing it, right? So it feels like any other language. So suppose you have there, and then you do X plus 1. Do you realize that this could be either R or Python? You would get the same effect, isn't it? Right. So not very different. Where the different things come in is when you try to create complicated data types and so on and so forth, or functions. So how do you do functions? One thing that you find very interesting is it has a native support for complex numbers. Python also has, but here you have it directly. Do you notice that? Right. So you can do complex number multiplication. Do you know what complex numbers are? I hope most of us know. 5 plus 4 plus 2 imaginary, right? And you can, it supports. So it is the, sorry, what did I do wrong? 1 plus, oh, sorry, M, I typo. Okay, there you go. So this is the multiplication of those two complex numbers. Then how do you create multidimensional arrays and so forth? So all of that, you have examples. You just look at the examples. Now, most of these examples will look very similar to Python. So it is very, very similar to R and Python. So that's why people say that it walks like Python, but runs like C. The performance of this language is comparable to C. Right. So that is the beautiful thing. And you can call C functions from within. You can see, you can directly call C functions, etc. It has a very good integration. It also has integration with Python. So you can call Python from this. So it's a new language. It's a lovely language. You have to give it time though. 3-4 hours will make you comfortable, but it will take you a couple of weeks to master it. And the way see, for example, you look at this function. How are functions defined? Do you see this, guys? Right? I'll just put it here. Where are functions? Sorry. Creating, calling, and functions. I want to take an example from here. Base, essentials, constants. By the way, it has pretty rich iterator and support, array support, and so forth. But more importantly, I want to show the functions. Right? So you can actually do, let me just write a function here, copy paste a function here, and you will see. So you can write a function, let's say, how would I do that? Paste, copy, paste. I'm not able to paste it here, so I'll just write it there. X function. So function f xy, right? Xy. Then sorry. Well, I'm not able to write it. I would typically do it in an editor, but just look here. What it helps you do is, if you look at the syntax of it, does it remind you of Fortran? Some of you would be reminded of Fortran, you know, ending the functions or routines with end and so forth. And the wording is so straightforward. We use the word function. Not only that, look at this one. In the function names, you can have sigma. It is such a easy way to, let me just put it this way. Well, here I can't put sigma because sigma is not there in the keyboard. But imagine writing code like this, right? The one that you have highlighted here. If you're summing up numbers, isn't this sigma xy as a function name very illustrative of what you're trying to do? These things you can only do in, as far as I know, only do in Julia.
Wow.
It's just amazing that you can write so expressive, mathematically expressive functions and things like that. So yeah, go ahead.
Now, how do you write sigma here? Like, it's not on the keyboard, right?
It is a Unicode. So in your editor, you have to enable Unicode and insert sigma.
I see.
It's doable.
Okay.
It's nice actually that you can do that. I mean, you can put character names, you can put whatever, Hindi or Chinese or whatever it is. It's because it's Unicode. So you can name your functions much more broadly than you would do in R and Python or Java, where everything must be alphanumeric.
It's pretty powerful, yeah.
It's a wonderful language. It's a future, but it's a young language. It is on the rise. It hasn't become dominant yet. If you pick it up now, by the time other people learn about it, you would be a guru of it. All right, guys. So before I close, I just wanted to mention this weekend, the talk is on word embeddings. This topic of what are word embeddings in text, of course, it's a broad topic. Well, obviously, these places don't explain it well. We will talk about word to vec. Actually, one good thing that I may recommend is there is a website called Towards Data Science that has very good articles. You can go and search for good articles there. So, for example, word embeddings may have, here we go, word to vec and so forth, exploration, explanation with code in Python. Except that, yeah, so read these things if you want, or come to the talk. If you come to the talk, in a very simple way, we can explain you in half an hour or 1 hour what word embeddings are. And then after that, you can come back and read these articles, and these articles will then feel very easy to understand. That's it, guys. I don't have anything else for today. We couldn't do code walkthroughs because we haven't done anything in practice yet. And theory also, the real thing will start from next week. If you don't have any other questions, then I'll end the meeting.
Thanks, Asif. This has been very helpful.
Yeah.
Have a good night.
Good night.
Thank you.
Thank you, Asif. Good night, guys. Bye-bye.
And we can let other people know about the embedded word seminar on.
Yes, yes. In fact, I posted it to our Facebook, Twitter, and LinkedIn. So
Okay,
every week I'll be posting to the social media sites, and on YouTube, of course, I'll be doing live.
Excellent.
Asif, you will be posting the recording and your notes also.
Today's recording, yeah, definitely.
Yeah.
Post it for you guys.
It's important to refer back to this.
All right, guys. Anything else?